Picture a fishing net, thousands of feet long, hanging in the dark water like a wall nobody can see coming. For a fish, swimming into it is the worst luck in the ocean. Except, what if it wasn't luck at all? What if, generation after generation, some fish were quietly winning a game they didn't even know they were playing? A game where the prize for staying small, staying quiet, and growing up fast was simply staying alive. That's exactly what's been happening under the surface of every ocean we fish. And it's not a slow, ancient kind of evolution either. This is evolution happening in decades, sometimes less. You have watched more evolution happen in fish than most textbooks ever described in humans. Here's the setup. For most of history, humans caught fish with hooks, spears, small nets, inefficient, small scale, barely a dent in the population. A single fisherman with a hand line could work an entire day and bring home a dozen fish. The ocean barely noticed. Fish, meanwhile, had spent tens of millions of years evolving under pressure from other predators. Bigger sharks, bigger seals, hungry birds picking off anything too small to defend itself near the surface. The rule those predators enforced was brutally simple. Get big, fast, because big fish survive predators, and big fish make more babies. Size was the whole game, over and over, for longer than humans have existed as a species. The biggest, oldest fish in a population weren't just lucky. They were often its most important breeders. A large, mature female cod, for instance, can carry millions of eggs in a single spawning season, far more than a young small fish ever could. So evolution kept doubling down on the same formula. Grow big, grow old, breed as much as possible once you get there. Those genes won, repeated across the population, for longer than we can really picture. Then, within the span of about 100 years, everything about that equation changed. Industrial fishing arrived, steel-hulled trawlers that could stay at sea for weeks, nets the length of football fields, dragged behind boats powerful enough to pull tons of fish out of the water in a single haul, sonar that finds a school of fish from miles away, turning what used to be a guessing game into something closer to a targeted strike. And here's the part that changes everything. Those nets don't take fish at random. They're built with a specific mesh size, engineered on purpose to let small fish slip through the gaps and catch the big ones, which, on paper, sounds almost responsible. Protect the babies. Take the adults. Let the population keep replenishing itself. Except that single, well-intentioned design choice flipped millions of years of evolutionary logic completely upside down, and it did it almost overnight on the timescale evolution usually works on. Because now, being the biggest fish in the sea wasn't the winning strategy anymore. It was a death sentence. Think about what that actually means for a fish. For millions of years, the genes that pushed a fish to grow big and grow slow were the genes that won. Suddenly, those same genes were swimming straight into a wall of net every single season. Meanwhile, the fish that matured early, the ones that stayed small, bred young, and never got big enough to trigger that net, those fish kept slipping through. Not because they were smarter, not because they were trying to escape, just because their bodies happened to mature at a size the net wasn't built to catch. And every single one of those small, early breeding fish passed that exact trait onto their offspring. To see exactly what that does to a population, you don't need to imagine it. You can watch it happen to one of the most famous fish in the world. For centuries, Atlantic cod off the coast of Newfoundland were giants. Fishermen told stories of cod so large and so plentiful you could supposedly walk across the harbor on their backs. These fish used to take 8, sometimes 10 years to reach reproductive maturity, growing slowly toward enormous sizes before ever laying an egg. Then, starting in the mid-20th century, industrial trawlers arrived, and cod fishing exploded into one of the largest fisheries on Earth. By the early 1990s, something had gone badly wrong. The cod population didn't just shrink in number, it collapsed. Nearly 90% of the breeding stock gone in a matter of years. A crash so fast that scientists studying it still describe it as one of the most dramatic wildlife collapses ever documented. Canada shut the fishery down entirely in 1992, putting nearly 40,000 people out of work overnight in what remains one of the largest single-day layoffs in Canadian history, all because the fish that built entire coastal economies had almost vanished from the water. Whole towns that had fished the same cod grounds for nearly 500 years, since long before Canada was even a country, watched their entire way of life disappear in the space of a single fishing season. Nobody in Newfoundland thought the cod could actually run out. It had always been there. And then, one year, it just wasn't. The fishery stayed closed for years. Scientists expected the old cod to come back, the way a forest grows back after a fire. Slowly, but eventually looking like it used to. That's not what happened. The cod that returned weren't the same cod. The average age of maturity had dropped. Fish that once took the better part of a decade to reproduce were now doing it in half that time, sometimes less at noticeably smaller sizes. And that's when researchers realized something far stranger than a simple population crash had taken place. This wasn't fish just having a rough environment, something that should fix itself once conditions improved. Researchers comparing genetic data across generations found the change was heritable. It was baked into the population, passed from parent to offspring like any other inherited trait. The nets hadn't just removed the big cod. Across decades, they had quietly voted for a different kind of cod to inherit the ocean. And stopping the boats couldn't undo a vote that had already been counted. Run that same selection pressure through 20, 30, 40 generations of cod, and you don't get a population that's occasionally smaller. You get a population that has permanently, genetically rewritten what normal looks like. And unlike a lot of the evolutionary stories you hear about, this one didn't take millions of years, or even thousands. 40 generations sounds ancient, like something that belongs in a fossil record. It isn't. A fisherman could watch the beginning of this process as a young man, watch it accelerate through his working life, and still be alive to see the fish looking noticeably different by the time he retired. And if you think cod are an isolated case, they're not. Salmon populations show the same pattern, maturing earlier and at smaller sizes in heavily fished rivers, sometimes returning to spawn a full year or two younger than their grandparents did. Herring, mackerel, plaice, dozens of other commercially fished species show the same fingerprint if you know where to look. A population quietly shifting its whole life strategy because of one thing, which individuals survived long enough to pass on their genes. And size isn't the only thing humans can accidentally select for. Even freshwater fish targeted by sport anglers, not industrial trawlers, show hints of this same pressure at work. Populations of largemouth bass in heavily fished lakes have been found to grow more cautious and harder to catch across successive generations. Not because any single fish learned a lesson, but because the boldest, easiest to catch fish simply got removed from the gene pool over and over, until caution itself became the inherited trait. Here's what makes this so different from almost every other story of animals adapting to us. When foxes adjust their behavior around cities, that's learning. That's flexibility within one lifetime, the same fox figuring out that trash cans open easier than rabbit burrows. This is not that. A cod cannot decide to mature earlier the way a fox decides to raid a dumpster. This is natural selection running exactly the way Darwin described it a century and a half ago, mechanically, blindly, inherited by their offspring one generation at a time. Except the predator applying the pressure isn't a bigger fish or a hungry seal anymore. It's us and our nets deciding, without ever meaning to, without a single fisherman ever intending it, which genes get to continue and which ones quietly die out in the water forever. And the science on why this actually matters goes even deeper than the fish got smaller. A smaller, faster maturing fish lays far fewer eggs across its entire lifetime than a large, slow maturing one would have. A large old cod can produce vastly more eggs over its lifetime than a small young one ever will. So even once a fishery recovers on paper, with population numbers technically bouncing back after decades of protection, the ocean is quietly less productive than it used to be. That's because the genetic variants that favored large, late maturing fish became far less common while the nets were running at full scale, before anyone realized what was happening. You can't simply reverse decades of selection by stopping the nets. This is why some fisheries scientists now argue that recovery isn't just about how many fish are back in the water. It's about whether the right genes ever made it back at all. And more than 30 years after the collapse, Newfoundland's Cod'ss still haven't fully returned to their old size, or their old numbers. There is a strange kind of symmetry hiding in all of this. Humans built nets to be smart, selective, sustainable sounding even. Let the babies go, take only the grown ones. Exactly the kind of rule a wildlife manager would write with the best intentions in the world. And that exact logic, applied at an industrial scale for decades across oceans on every continent, became one of the fastest, best documented cases of human driven evolution in any wild population on Earth. Faster than almost anything conservationists have tracked in a mammal or a bird. We didn't mean to redesign an animal. Nobody sat down with a plan to make cod smaller. We built a filter, and the ocean, the way it has always done for billions of years, simply adapted to the filter. The same cold, patient, indifferent way life adapts to literally anything standing between it and survival. It's worth sitting with how strange that actually is. This wasn't a slow drift caused by pollution, or a changing climate nudging fish in some vague direction over centuries. This was millions of individual selection events. A net closing, a fish caught, or a fish slipping free. Repeated so many times, across so many boats, over so many decades, that it added up to something as powerful as any force evolution has ever produced in the wild. Every single haul of the net was, in its own tiny way, a vote for which genes got to keep existing. So next time you're holding a fish on a plate, or watching one flash silver under a docklight, remember, you might be looking at the descendant of thousands of generations that learned, without ever knowing it, to stay small enough and grow up fast enough, to slip through a wall in the water that was never built with them in mind. Not by being clever, just by being exactly the fish the net wasn't looking for, because that's the quiet, unsettling truth about evolution. It doesn't care about size or strength or how impressive an animal used to be. It only cares about what survives long enough to pass itself on. And for the last 100 years, in oceans all over the world, we've been running one of the biggest evolutionary experiments in history, one net at a time, without ever writing down a single hypothesis.